question we'll be working through today is from the 1983 competition, and only 5% of students got this one right. So the question is, in his will, a father leaves all his money to his children in the following manner. The first child gets $1,000 and a tenth of the rest, the next child gets $2,000 and a tenth of the rest, and the third child gets $3,000 and a tenth of the rest, and so on. Now, once this is done, all the children end up with the same amount of money. So we have to work out how many children there are. So pause the video here, have a go, and then come back and see my solution. Okay, how did you go? I think this question is really probably a bit too hard for students at this level, but it is such a great one for people who are just learning algebra because, first of all, it's going to give you an appreciation for what algebra is for, because you can do this question without formal algebra, but it's really hard. It's much easier with algebra. So that's going to show you what algebra is for. And also it's going to give you an overview of all the different parts of algebra, expanding, simplifying, solving equations, and it's going to show you what all those things are for. So don't worry if you didn't get very far with this question. I know it is a really hard one for kids your age. So what I would do first, and what's really useful for all sorts of questions, is to try to draw a picture from the information you have. So what you could do for this one is draw like a stack of money. So if you imagine like this is all the money, like a stack of bills that the father's leaving to his kids. Now the first child takes $1,000, so let's just sort of take a bit off the top and say that's 1,000. And then also a tenth of the rest. So however much money is left at this point, we want to take off a tenth of that. So I might just cut a bit off and say that's a tenth. Okay, so all of that bit is what the first child gets. Now, the second child takes off $2,000. So I'll draw that in. And then a tenth of the rest. So however much money is left at this point, the second child also takes a tenth of that. So let's draw that in as well. Okay, so all of that is what the second child gets. So I'll show you the non-algebra solution first, and I really think that this was much harder to come up with than the algebra solution. Once you get used to algebra, algebra is quite easy. So what you could do here is you could say, okay, this amount of money has to be the same as this amount of money, right? Because each child gets the same amount. And because this part is 1,000 more than this part, that means that this part has to be 1,000 less than this part. I hope that makes sense to you. Don't worry too much if this doesn't make sense, because that just demonstrates how useful algebra is, because you don't have to do any of that kind of thinking once you do the algebra solution. But okay, so I'm saying this bit has to be 1,000 less than that bit. Now, because this is a tenth of whatever amount of money it was here, and this is a tenth of whatever amount of money it was here, that means then this has to be 10,000 less than that. Again, I know this is really confusing. This is why we really need algebra for this question. So hopefully that did make some sense to you though, that this is 1,000 less than this, and because this is a tenth of there and that's a tenth of there, then the difference between these 2 points has to be 10,000. Okay, now if that amount of money is 10,000 and this is 2,000, that means this bit has to be 8,000. I'll just write that in there. So that bit there is 8,000, and that is a tenth of the amount of money here. Therefore, this amount of money has to be 80,000. So 80,000 is like that whole bit of the stack. And therefore, the original amount of money, like the whole stack up to here, that has to be 81,000. So then from there, so we've got 81,000 is the total. let's work out how much the first child gets. So that was 8,000 there, and you've got the 1,000 there. So $9,000 is what the first child gets. And then the second child will also get 9,000, if we've done things correctly. So we can work out how many children there are by doing 81,000 divided by 9,000. And that'll give you 9. So 9 children is the answer. Now I want to go through the solution using algebra, which may look confusing at first if you haven't done much algebra, but it is actually easier with algebra. So what you can do is maybe we call the amount of money at this point x. So we don't know that amount of money yet. You could also call the total from there x, but it actually comes out more complicated if you do that, so I decided to call that amount of money x. So if that's x, and this is a tenth of that amount, this is actually x divided by 10. So I'll just write that in. So that's x over 10. You could also say something like it's 1 over 10 times x, or x divided by 10. Those are all the same thing. Okay, so that's x over 10, that's 2,000. Therefore, the amount of money that we have there is x, so that level, minus that and minus that. And then this, which is a tenth of this amount of money, is just going to be like that divided by 10. So now we can actually use that to make an equation. And this is the most important part of algebra. Like actually solving equations is something that computers can do for you. So in the real world, being able to turn all these words into an equation is a much more useful skill than being able to solve equations. So that's what you should really concentrate on the most. And I think it's probably the most interesting part of algebra. So what we want to do is just take this information that each child gets the same amount of money and turn that into an equation. So that's just like this bit equals this bit. So that's 1,000 plus the x on 10. So that's the amount of money that the first child gets. That has to equal this amount of money, which is 2,000 plus a tenth of that. So you can write that as like 1 over 10 times that, or you can write it as like a fraction as like x minus x over 10 minus 2,000 all over 10. All right, so now we've got the equation. And actually, if you wanted to use a computer to solve it, you would pretty much be done now. You can just type that into I'll just show you how to do it with Wolfram Alpha. If you go to wolframalpha.com and just type in solve and then the equation that you want to solve and hit enter, that will give you the solution. So a computer can actually do all of the equation solving for you, which is why that isn't the most important part of algebra. Like, you need to know how to solve equations to pass your tests in high school, but in the real world, the being able to write down the equation in the first place, that's the important part. But of course, I'll show you how to solve this by hand as well. And I just wanted to mention that if you did the equation in terms of the amount of money at the start instead of the amount of money here, you would have x minus 1,000 wherever I have x there. So just in case you wanted to check your equation if you wrote it down that way. All right, now to solve this, the basic idea with solving equations is that you want to do the same thing to both sides of the equation. So in this case, the first thing I would do is move the 1,000 over. Like, I want to get rid of that and shift it over to the right. And the way that you do that is to subtract 1,000 from this. And because we're doing that to the left-hand side, we also have to subtract 1,000 from the right. So when you subtract 1,000 from this, you get x on 10. And then over to the right, we subtract 1,000 there as well. And so this just becomes 1,000. So that's cleaned up the equation quite a bit already. It's now a little bit simpler. And interestingly, that corresponds to the first thing that I did with the non-algebra solution, because the first thing I said was that this one would have to be 1,000 less than this, and that's exactly what this equation is saying. It's saying that the x on 10, which is that bit, is 1,000 more than this bit. So what I would do next, because we've got these fractions, it would really clean things up if we multiply both sides by 10, because that's going to like get rid of these fractions. Because if I multiply this by 10 on the left, we're just going to get x. So because I've done that on the left, you also have to multiply the right-hand side by 10. Now, some people, when they're starting out with algebra, they find this a bit confusing, how to multiply this whole thing by 10. So I'm going to write it out like in 2 steps, because I think it becomes easier if you do an intermediate line like this first. So now what we need to do is expand this. So that means we need to do the 10 times the 1,000, and then also have 10 times this. So 10 times 1,000 is just 10,000. And then when we do 10 times this, the 10s are just going to like cancel out, because we're multiplying this by 10 and then dividing it by 10. So we're just going to get what's on the top here. X minus x on 10 minus 2,000. Okay, now that actually corresponds to the next thing I did, because if you remember, what I said after that was that the amount of money here has to be 10,000 less than the amount of money here. So what I'm doing in the algebra is like perfectly corresponding to what I was doing in the non-algebra solution. All right, what I would do next is combine the 10,000 and the negative 2,000. So that's called collecting like terms, I guess, or just simplifying. So 10,000 minus 2,000, that makes 8,000. Okay, and then what I would do, because on the left we've got just x, what you want to do when you're solving an equation and there's like a bunch of x's everywhere, you want to move all the x's over one side of the equation. So what I want to do is take this x and this x on 10 and shift them over to the left. Now the way you do that, I'll do that in 2 steps. I'll shift the x over 10 first. So what I want to do is add x over 10 to both sides, because if I add x over 10 to this side, then that's just going to cancel with the minus x over 10, and that's going to disappear. So I'll add x on 10 to this side as well. So we've got x plus x over 10. And then on the right, we've got 8,000 plus x. We've got like minus x over 10 plus x over 10, so that's just nothing. And then I'll move the x over to the left as well. Now, because that's just going to cancel with this x, if I subtract x from both sides, that's just going to get rid of that and that. So what you can actually do is just put a line through that and that to say that they're both gone. Okay, so now we've got x over 10 equals 8,000. And that was actually the next bit that I did here. I said that this is 10,000 and this is 2,000, therefore that bit has to be 8,000. Okay. Now what I would do next with this to work out what x is just multiply both sides of the equation by 10. So on the left that gives you x, and on the right we multiply that by 10 as well, and that gives you 80,000. Okay, so then that tells you the amount of money that was there, and then again you just add 1,000 to that to get the 81,000 as the total, and then once you've done that you can work out that that's 9,000 and that therefore there are 9 children. Let me know in the comments if you're still confused about anything in this question or about maths in general, and give this video a like if you want me to make more like this.